Okay, another type of synthesis problem. Right, this one asks you to add an appropriate reagent to complete a transformation. All right, look at the first one here. So I have this compound with an iodine. All right, and I want this as a product. First of all, this one will be easy if you know the mechanism. Okay, so determine the mechanism first. Look at an alkyl halide. All right, this is a primary alkyl halide. Do you want to do SN1 or SN2? And SN2. Can you do SN1 though? No. Primary carbocation is not stable to do an SN1. So your option going to be an SN2. Okay. So this is going to do an SN2. So backside attack requires a strong nucleophile. Not just any strong nucleophile though. It's going to be a nucleophile that looks like that. Ethoxide group. That and ethoxide. So we need a strong nucleophile, basically like a negative, or with a negative charge, and then an ethyl group. All right. So what reagent that can be looks like this and can accomplish this transformation? Well, there are many things that you can use: lithium ethoxide, sodium ethoxide, potassium ethoxide. Pick one. Right. The common one is sodium ethoxide. It's cheap. Really cheap. Not ethanol. Not ethanol. Ethanol is a weak nucleophile. All right. It won't do this reaction there. All right. So we're going to add a sodium ethoxide and go SN2. You should get that product. Okay. All right. Next one down here. If you look at the structure of an alkyl halide, you should know this is going to go in SN1. It doesn't go SN2. Tertiary block SN2. All right. So if this were to go in SN1 reaction, we want a weak reagent, right? We want a weak reagent that looks like methoxide, the methoxy group there, all right? The weak reagent that look like methoxy group there, well, methanol. Just add methanol there. This is a weak one, all right? Now, next one, if you look at the starting material and the product does an inversion of configuration. See that? It got inverted, the configuration. This is going to be an SN2 for sure, all right? If this were to be an SN2, we want a strong nucleophile that looks like that. We call it an acetate group. Right? This group right here, we call an acetate group. So we can use sodium acetate, potassium acetate, lithium acetate. I never seen lithium acetate before, but yeah, sodium acetate is like the most common one. Anything sodium or potassium. All right. You're probably familiar with acetic acid. If this oxygen covalently bond to hydrogen, that's acetic acid. Now the whole group here we call acetate group. All right. Next one down here. All right, what we got? Oh, this should be simple to you. Can you see this in an SN1 reaction? Tertiary, totally go SN1. But notice that your leaving group here is the poor leaving group. Yeah. OH is the bad leaving group, so you have to convert that to a better leaving group first. And there are multiple ways to do it. You can use a HX halide, right? Hydrohalic acid, hydrochloric acid, bromic acid, iodic acid, or use tosyl chloride, right, to convert a better leaving group. But in this case, we want a bromine on this carbon, so use hydrobromic acid. Work just fine. All right, add hydrobromic acid. So the first step going to be a proton transfer, become a better leaving group. Leaves and bromide attack. That you get that. All right. Next one. Let's see. All right. So if we want this to go two ways, if we want this to go way at the top, right, this route, let's see what happened. Inversion of configuration. The configuration is inverted, so this is going to be an SN2. So we want a strong nucleophile that looks like that. Who should we use? Well, this guy right here, making an ionic bond on the oxygen, potassium or sodium, and this compound. That works. That's an SN2. All right, down here, come down here. So it looks like what we got there. Oh, racemization for sure. Oh, one thing. Hold on. The reaction center has changed. You see that? This carbon here is supposed to be the reaction center, but the product, we got this thing attached to the carbon on the left, right? Totally, this is SN1 reaction. This should, you should recognize rearrangement and racemization in here happen at the same time. All right. So racemization, you get the enantiomers, racemic mixture basically. And rearrangement, so there's a change of reaction center from this carbon to the carbon on the left with the methyl group there. Right? So this guy attacked the carbon on the methyl group. That tells you there's a rearrangement. Okay, so it looks like there's a hydride shift there because no methyl shift chain, no carbon chain. There's going to be a hydride shift. Hydrogen right here. Hop on to the carbon on the right, leave the carbocation on this carbon, which is tertiary, which is more stable than the secondary. So it's good. Everything makes sense there. All right. So this is going to be an SN1 reaction. So we want this compound as a weak nucleophile. Well, alcohol, it works. That's an alcohol. Okay. So we call cyclopentanol. Cyclopentanol. Work as a reagent and a solvent, right, for this reaction. All right, next one. I think that's the last one. Okay, cool. What we got here? Let's see. You should be able to see that racemization. These two are enantiomers. Getting 50-50. It should be an SN1 reaction. And the reaction center has changed from this carbon on the right to the left one. Yeah? So there's a methoxy group attack carbon on the left side, on this left, right? So this is an SN1 reaction, okay? Just to review real quick, so OTS, that's a toysylate group, so look like that. This is OTS, all right? So we use these are excellent leaving group. We use this to convert an alcohol. If you were to have an alcohol, we add TSCl, which is tosyl chloride, which is basically this group right here. This is chlorine. This is chlorine right here. It replaces oxygen with chlorine, right? So there's a tosyl chloride. Pyridine is added as a base. You will learn this in a couple chapters ahead of us. So convert OH to an OTS, which is an excellent living group. That's how it works. That's what it's for, basically. Anyway, so this is already a good living group, so we don't have to do anything about it. Right? We don't have to do this step. All right, so good living group, ready to leave. And if you recognize rearrangement and racemization, it tells you this is go SN1. All right. So we want a weak reagent that looks like a methoxy group there. Just use methanol, right, as a solvent and as a nucleophile. All right, that's how you do it. Again, practice make perfect. You won't be good at synthesis if you don't do it. I have a lot of problem for you for synthesis on the study guide. Make sure you take a look at it. Okay. Chapter 7, class activity activity 8, question 1 and 2, and that's it. All right. We have a hint right here. Give you a hint. Okay, let's move on to the last video of this chapter.